Ulit.
Start ko na lang.
Sige. Sabi mo lang. Sabi mo, kalabitin mo na lang ako, okay na. Good day to each and everyone. First, we would like to thank our subject advisor, Engineer Rex Maldicapia, to our panelists. Thank you for the time you have given us, and also to our title advisor, Engineer Noe Domanais, for the continuous support all throughout. I would like to introduce myself as well as my group mates. I am Julicel M. Abarico.
I'm Carlo Ordinado.
I'm Van Joseph A. Hinton.
And I'm Jason Bikidia.
We are here to present to you our study titled Design and Fabrication of Seawater Desalination based on humidification dehumidification process. The outline of the presentation starts from introduction and background of the study, objectives of the study, significance of the study, scope and delimitations, related literature and study, research paradigm, conceptual framework, system design, estimated bill of material, and lastly, project testing and evaluation. Water and energy are two of the most important topics of the international environment and development agenda. The social and economic health of the modern world depends on sustainable supply of both energy and water. Many areas are worldwide that suffer from freshwater shortage are increasingly dependent on desalination as reliable and non-conventional source of fresh water. Seawater desalination has the potential to reliably produce enough potable water to support large populations located near the coast. Desalination is the process of removing salt from saline sources and is technologically feasible process to provide potable water. Desalination is a good technique to provide technically freshwater supplies, which are used in various fields. The existing desalination plants are mainly large scale, huge energy and material requirements leading to high ecological footprints are some drawbacks of these plants. Also, large scale plants are only affordable to the rich countries and unsuitable in many developing countries and remote locations. Development in desalination technologies are specifically aimed at reducing energy consumption and cost. However, most of current desalination technologies consume large amount of energy. For the purpose, a new water desalination system has been developed through the integration of dehumidification. All technologies are good for the desalination of salt water. However, these are often not suitable for remote areas or in use domestically due to the large infrastructure associated with them. Therefore, the small capacity desalination units are in an effective solution for for the provision of fresh water in remote areas and home use. In comparison with other desalination methods, the humidification method has a number of advantages such as simple design, flexibility, low maintenance, capital cost, utilization of low-grade energy, applicability in decentralized areas for supplying the freshwater. As mechanical engineers, the proposed process that design water desalination using the humidification dehumidification process to find its full potential and significance towards small communities and with a limited number of instructional materials for development. This study impacts as an additional learning platform for the students in mechanical engineering. The main objective of the study is to design and fabricate a water desalination system. using humidification dehumidification process. It is our main objectives. Specifically, the proponents aim to prove that it can produce fresh water with less energy consumption, to determine the latent heat recovered during vapor condensation, to determine the amount of fresh water produced in different feedwater temperature conditions, to be used as a material for instructional purpose of ME students, to select equipment or parts suitable for humidifying, dehumidifying, and heating of seawater, scope and delimitations. The scope of the study is on design and installation seawater desalination system using humidification dehumidification process. This design is suitable for remote as well as small population regions. It will be more focused on the process inside the system and the effect of different temperature of seawater when it comes to freshwater output. Furthermore, the collection of feed water for prototype testing will come from Baseco Beach. This research, however, is subject to several limitations. The desalination system is only designed to treat seawater for household and agricultural. Brine concentrate disposal and process is not part of the study. The process of solar water heating is also not part of the study. Fresh water produced is not recommended for intake unless output water testing is conducted. The feedwater temperature from solar collector will range only from 80 to 90 degrees Celsius.
Next is Ban Joseph.
Yes, for our chapter 2 for review of related literature and studies, I am going to discuss it based on our research. So, here are the information we gather in our related foreign literature. So, as mentioned in the introduction, there is most most need and most important need uh, in the people in our community is the water. So there is a clear need to help create a sustainable solution to the rural water problem in order to solve the global water crisis. And the minimum water needs for drinking and cooking for each one of those communities is between 10 and 100 cubic water of pure water per day at consumption rate of 10 liters per person per day. And in our topic proposal, desalination process, uh, here is the uh, principle. In like the rain cycle, nature uses air air as carrier gas to desalinate seawater by means of rain cycle. In the rain cycle, seawater gets heated by solar irradiation and evaporates into the air above to humidify it. The HDH process thus promise higher productivity due to separation of the basic processes. The HDH systems are ideal for the application in small-scale systems. So the HDH system may be classified under three broad categories. One is based on the form of energy, and the second is based on the configuration, which is uh, which is uh, closed air open water or closed water open air. And the third is by heating the water or the air. Next slide, please. Next. So another information gathered for related foreign study. Here are the advantages of the HDH. For our humidification and dehumidification can be advantageous in the decentralized, which means in the places that cannot be reached in the in Maynilad or any other big water production. Off-grid desalination applications where water treatment demand ranges up to several thousands cubic meters per day. HTH has recently been commercialized and has in succeeded in treating produced water from hydraulically fractured oil and gas wells. So before the HDH known, it is also known as a solar steel. And a solar steel is typically consists of an inclined glass covered above a pool of saline water. Sunlight passing through the glass hits the water, causing evaporation. The water after air preheater and humidification is then recirculated back to the solar water heater by centrifugal pump. So this is the process of our HDH system when it comes to solar steel. Next slide, please. So this is our uh, based research information gathered based on our related local literature. Water scarcity is growing around the world, including the Philippines, and existing water resources are already under stress, especially on summertime. And this is getting worse. So locally, the onset of the El Nino phenomenon is going to make water even scarcer in Metro Manila. And one of the solution is the desalination process that removes salt and other dissolved contaminants in saline water. And also, the solar power can help solve the energy factor in desalination. In fact, in Cebu City, government signed a joint venture agreement to put up a 750 million water desalination plant that is projected to supply 22,000 cubic meters a day, although the plant can supply as much as 50,000 meters a day. Next slide, please. Chapter 3. In
This
chapter
is
3,
chapter 3, research methodology. We have Jason Dibilia.
This is our Gantt chart, and we are starting in choosing our subject for this project study. In our plan, we estimated it just for 2 weeks, but in actual, it will take 4 weeks because we need to study, making sure that we are all familiarized for the subject. And then the next week, we gather all the information for our chosen subject. We plan it for 2 weeks, but due to the extension of our previous plan, we moved the following 2 weeks. And then on the second week of our Gantt chart, we are looking for an advisor to our design. And we are so lucky that one of our professor accepted our proposal, and he completely gave his support and helpful advice for this project. Then the following week, which is the 7th and the 8th week, we starting doing our chapter 1. The introduction, searchings and analyze the background of studies for the chosen subject, and then our objectives, which is the general and specific objectives. After 2 weeks of compilation, we also do the chapter 2, and we share it to our advisor. Our advisor share his knowledge and lay down some comments for the topics on the studies. Then we comply it in his suggestion, and then the following week, which is the ninth week, we do some revision, and also we do the simulation, and we try to all the finish the report. Next. Uh, these are searching. This is our search paradigm, which is we categorize it in three sections. It is the input, process, and the output. In the input, we start in the knowledge requirements. We just come up with a seawater desalination, and then water treatment, which is we need to check the output of our this project or design, and then the fluid mechanics and machine design. The second is hardware material requirements, which is fabrication of the machine and the selection of the materials, selection of parts, and the computation of our design. And this next is the software requirements, which is Microsoft Office and SolidWorks. In Microsoft Office, we do all the paperworks, all the research, and the SolidWorks is we will do the design. Which is but in a people requirement, which is us, the researchers, and the advisor. In the process, we start in identifying the problem, which is mean we need to know what and where do we use the machine and how it works. And then we gather all the data that we need for the design, we need for the project. And then the next is conceptualizing and designing. In this stage, we do the computation of the machine, we do the computation of the parts, and the selection of the components that we need for the machine. And then after the conceptualization, purchasing of materials, and then publication of our machine, the platform, and some other parts, and then assembly of of all components. And then after that, testing and evaluating the result. In testing and evaluation the result, if the result is okay, we go through the implementing the project, and then do further development for the no, for the project, and then we have an output, which is the humidification and humidification desalination process. And if it's not, we're gonna go back to conceptualizing and designing, and we will do all over again design. Next, please.
Next is identifying the problem. Included in conceptual framework, in this stage, the researchers found out ways to treat saltwater using dehumidification desalination system. Along with this, the researchers have encountered problems like seawater in copper tubes is usually used in a condenser, but it has shown the drawbacks of pipe erosion, high cost of the copper material, etc. In this case, the component to be used for our HDH system in instructional purpose for the student are dehumidifier, solar collector, or solar water heater for heating the seawater, plexiglass, aluminum tubular, and full cone nozzle sprayer, which every drop size can be so important for considering the overall entertainment of fluid within the gas flow. In this part of the study, it is important to identify the problem. One problem is the use of the component. We have the condenser. In the condenser, we use copper tubes. So we research for uh, element to element metal to use that will not corrode or rust. So we found out that copper nickel alloy is uh, is essential to use in the condenser. Next is the parts of the desalination system is the humidifier. We use packed bed to raise the efficiency of the evaporation in the humidifier. Next is the dehumidifier. We use the condenser to cool the mixture of air and evaporated water. Then the solar collector, we use it to heat the seawater. Then we use as a housing the plexiglass aluminum tubular to frame our design, and for spraying we use the full cone nozzle sprayer. Next is data gathering. The researchers adapted the idea of several studies about heat energy recovery in the dehumidifier or condenser to determine the heat recovery using the seawater as a cooling fluid in the condenser for conceptualizing of the design and selection of materials for this specific prototype. In this study, we have searched a way to recover heat from the condenser. So in order uh, to use to recover heat in the condenser, we use the as cooling fluid, the seawater. We use it to cool the steam coming from the humidifier to condense the steam to to produce fresh water. Next is conceptualization and design. We have here the actual design of our prototype. We have the solar collector to heat the seawater. Then the humidifier section, we have the packed bed, which is this blue this blue material, and then we have the dehumidifier section. We have the condenser and the demister to filter some evaporated, some salt water, and then we have the blower to increase the velocity of air. Then we have two containers here. At the bottom, we have the freshwater produced container, and then the saltwater that didn't evaporate in the humidifier, and we call it brine. Next is the component connection.
The component connection. This diagram I will show you the process and the flow of the flow of the flow of our machine. The process will start at pumping seawater to the humidifier, then preheat the seawater before it will go to a solar heater. Then fill the solar tank collector and heat up the water up to 85 degrees Celsius. Using a solenoid valve, the water will not continuously flow temper the water will not continuous flow when the temperature is not reached. And then due to the location of our solar heater is internal in the machine, we put a pump to meet the pressure requirement that we need for the water nozzle and system. And then when the temperature reached the requirements, the solenoid valve was open. The the high temperature seawater injected into the dehumidifier. We use spray nozzle to distribute the liquid into the humidifier section. And then we estimated that 5% of the water will evaporate and the 9% brine will be back on the tank and start the process again. Using a blower, the water vapor mixture pushed into the condenser. We use temperature of the seawater passed through the condenser to absorb the heat from the water vapor mixture and act as a dehumidifier. Then the the, the water the water vapor goes to the dehumidifier, and then using the temperature of the salt water, the condenser go to the condenser will reject the heat, and then using a blower, the water vapor mixture pushed into the condenser, which is act as a humidifier to cool down the water vapor and will condensate it to produce the fresh water. With the using of we put demester on the after the humidifier to prevent the droplet of the salt water to go to the humidifier and mix the salt water to the fresh water output. Next slide.
Next is the design calculation for HDH system. This is the theoretical calculation for our design. We have to show possible humidification paths and exit states of the air. We have the all these values from our calculation. First, we have to know the recovery ratio, which is the 5% recovery ratio of fresh water produced. We have the permeate mass flow rate 0.07667. This is the mass flow rate of fresh water produced. And the next is the minimum feed flow rate, which is 1.533 times 10 to the negative 4. We also have the mass minimum feed flow rate of air and salt water, which is 0.1579. Then the permeate concentration based on our research, which is in Baseco Beach, the salt concentration or permeate concentration is calculated as negative 0.2375, which is also equal to zero for the permeate concentration in a in desalination. Next is the concentration factor of the seawater and freshwater. We have 1.053, and based on the assumption of the temperature in air, we have the inlet temperature of 31.6 degrees Celsius and the outlet temperature of air, which is 77.9 degrees Celsius. We come up with the outlet and inlet humidity ratio of air based on our calculation, given the saturated pressure and atmosphere. We have 0.4680 kilograms of water per kilograms of dry air. In the outlet humidity ratio of the humidifier, and 0.02799 kilogram of water over kilogram of dry air as a humidity ratio. Next is the enthalpy of mixture of dry air and water vapor. We have based on the calculation, the formula given in the refrigeration and air conditioning, we come up with the enthalpies of 1313.486 kilojoules per kilogram as an outlet enthalpy, and 108.119 kilojoules per kilogram of inlet enthalpy. Next is the component calculation of our design. We have the solar water heater. The heat added in the solar water heater is 32.07 kilowatt, and the gain output ratio, which is 0.8485. It is the ratio of latent heat needed to evaporate fresh water evaporate fresh water from humidifier section. Next is the effectiveness of HDH system. We come up with the efficiency effectiveness of 85.72%. Then is next is modified heat capacity ratio, the ratio of enthalpies of the the enthalpy of the seawater and divided by the difference enthalpy of the air. Next is the solar water heater efficiency. We have 85.58% based on our calculation. Next is the calculation in blower. We come up with power required, which is 13.30 watts, and the blower efficiency of 79.58%. Next component is humidifier. We have heat absorbed by air, which is 12.78 kilowatt. Then we come up with this calculation based on cooling tower as a basis of our calculation. We have the range, which is 22.61 degrees Celsius, approach 46.3 degrees Celsius, and the efficiency of the humidifier, which is 46.71%. Next is dehumidifier. We have heat rejected in the condenser, which is 15.996 kilowatt, and the heat recovered, which is included in our objective, heat recovered or the latent heat, which is 5.65 kilowatt, and the outlet temperature, which is included in our calculation, is 39.99 degrees Celsius output temperature of seawater. Next component is feed water pump. We have calculated the total dynamic head based on the component needed, which is the hose and the other parts. We have 6.9961 meters, and the minor head loss, which is divided by the density of seawater and the uh, gravity, we will come up with the minor head loss. The pump power is 16.58 watts, the needed pump power. Next is the nozzle sprayer. We have the flow rate of entering this nozzle, which is 2.43 gallons per minute, and the calculated drop size of seawater is 0.001009 centimeters. Then the viscosity of seawater given in our research, we have 4.12 times 10 to the negative 5 cubic centimeter per second. Then the actual calculated diameter of nozzle is 5.698 millimeters. Next is estimated bill of materials.
Estimated bill of materials. Quantity 1 evacuated tube. Sorry, I have a quantity 1 set evacuated tube solar collector. A cost of 7,774.12 pesos. Condenser 2,500. Honeycomb 350 pesos. Spray nozzle 653. Seawater 915. Centrifugal air blower 2,408 pesos. Louver 3,077. Two pieces, equivalent to total cost of 6,154. Temperature monitor 200. Solar hot water pump 600. Two set of solar collector Cost 2,500 equivalent to 5,000. 2 pieces of demister, total cost of 3,688. 4 pieces of aluminum angle bar, total cost of 1,600. Plexiglass, 12 pieces of plexiglass, 15,408. 1 piece of solenoid bulb, 2,050. Push button switch, 2 sets, cost of 300. 12 pieces of fittings, male and female, equivalent to 5,640 pesos. 2 pieces of ball bulb, equivalent to 3,423 pesos. 1 piece of circuit breaker, 245. 1 piece of power supply, 425 pesos. Fabrication housing, fabrication cost, 5,000 pesos. And installation of the solar collector installation fee, 3,000 pesos. And summation of the total cost is 67,405.12 pesos. The R contingency fund, 10% of the total cost is 6,740.5. And the grand total equivalent to the total cost and grand contingency fund is 74,145.63 pesos. That's our estimated bill of materials.
These are our wiring diagram. In our wiring diagram, we put a circuit breaker for the safety of the control. Then we put the start and stop button when we open the machine, when we start the machine. And in this diagram, when you press the start, all the all the motors are working, but the pump depends the pressure switch. And then we put thermostat, which is the temperature controller for the solar connector. And we put the overload protector for the safety of all motors. And next is the power diagram. Next, on the power diagram, we put two contactor, the contactor for the fan motor and the contactor for the pump motor. And we also put the overload. This is the overload. This is the safety of the motor. And next, the operation and maintenance. Operation and maintenance is, we all know that is very important for the machine. But if we start on the maintenance, the first, when you're doing maintenance, is turn off all the power supply and shut off all the water valve to make it to for the safety of the maintenance or the technician. And then the second is check all the connections and gauges of the system once a month, at least once a month, and replace the broken parts if needed. And then open all the drain valves and do cleaning. We suggested that use only cleaning agent that's suitable for the machine and component. Example, this is the water desalination. This machine works in water. That's why we suggested use the soap and the scaling agent only. And then next is number 4. In this machine, we design that all the major components are accessible to to make it easy for the maintenance. Next, this startup procedure. During startup, we all need to know the familiarization of parts and components. This is important because
when we use a machine, we need to know the function of all parts for the safety, and then check the condition of the machine. Is it we need to check is it it's okay for the operation or not, because sometimes the machine we find the machine that some motors is not or not working, then or the sign of like there's a sign of like explosion or burn. That's why we need to check the condition of the machine. Then number three is the check connect the plug to the power source, and then switch on the breaker, and then turn on the machine. When you turn on the machine, you need to check the temperature controller if the set in the right temperature or the temperature requirements. And then we also check the indicator lights. The indicator lights is the we need uh, this indicator lights that indicates the machine is running, or the temperature controller is on the good condition. And then switch on the motor pump and blower. And then when we start the motor pump and blower, the machine will start operation. Next, uh, shutdown procedure. Uh, Shutdown procedure is one of the important also, because some other equipment or some user just turn off the equipment and then leave. But we suggested that when they turn off the machine, when they press the stop button, we need to wait for at least 15 to 20 minutes for the cool down of the machine. This is important because for the safety of the equipment and the end user. Then after that, switch off the breaker. Next, and done.